Between 7 to 9 million years ago, as the forests of North Africa began to fragment, and due to genetic mutations and changes in the body structure of some primates, these creatures developed the ability to stand upright and walk on two legs. Walking on two legs marks the beginning of the story of how we became human. The oldest fossil recognized as the first bipedal creature to date is a skull fossil without a lower jaw, discovered in Chad, Central Africa. This discovery was made public in 2002. The age of this fossil is estimated to be between 6 to 7 million years. It has been named Sahelanthropus tchadensis, and to this day, it is the oldest known actor on the stage of the human life drama. The Sahel is a region in the center of Africa that stretches from the Mediterranean Sea to the Atlantic Ocean. Anthropus means human in Latin, and tchadensis refers to the location of the fossil's discovery in the country of Chad. The discoverers of this fossil named it Toomai, which means hope of life in the local language. The position of the foramen magnum, the spinal opening, at the base of Toomai's skull indicates that this creature was capable of walking on two legs. The spine, along with the spinal cord, connects to the skull through this opening. In quadrupedal animals, this hole is tilted toward the back of the head, but in humans, due to our upright posture and bipedalism, it is located at the base of the skull. If we place the skull of Toomai on the neck of a quadrupedal ape, its eyes would point downward, which wouldn't make sense. However, when placed on the cervical vertebrae of a bipedal creature, the eyes naturally face forward. This strongly suggests that Toomai walked upright. Between 6.6 million and 2.5 million years ago, before the appearance of the first fossils belonging to the genus Homo, a variety of hominins lived across Africa, all sharing one common trait, the ability to walk on two legs. After Sahelanthropus tchadensis, other hominins such as Tchadensis, Australopithecus Robustus, and Australopithecus Sediba inhabited East Africa. However, the most important hominin genus before Homo was the family of Australopithecus. Paleoanthropologists named these creatures Australopithecus, meaning southern ape, as they had skulls, teeth, feet, and hands similar to early great apes and lived in Africa between 4.5 and 1 million years ago. Scientists have divided Australopithecus into two groups based on their body structure, gracile and robust. For the robust group, they proposed the name Paranthropus, meaning parallel to humans. Australopithecus itself consisted of several different species, for example, Anamensis, Africanus, Afarensis, Sediba, Garhi, and Bahrel-Ghazali. In contrast, the genus Paranthropus included three species, Robustus, Aethiopicus, and Boisei. Australopithecus and Paranthropus were social creatures that lived in small groups. Although their diet varied depending on their habitat and surrounding geography, they primarily fed on fruits, seeds, insects, larvae, small animals, and the remains of carcasses left by carnivores. These hominins were among the most successful species, managing to adapt well to a wide range of environmental conditions in Africa over a span of 3.5 million years. Archaeologists have uncovered their fossils in various parts of the African continent. These creatures were neither as agile in the trees as apes, nor as efficient on the ground as humans, yet their survival for millions of years is a testament to their success in nature. The adaptation of hominins to life outside the forests was a slow process. It seems that Australopithecus preferred marginal areas that included both dense forests and open spaces. Although they favored walking on two legs in less wooded areas, they didn't completely free themselves from the trees. These small, defenseless creatures still sought refuge at night in trees, on cliffs, and in other safe places. The anatomy of their arms, wrists, and hands shows that they could easily climb trees while also being able to walk through grasslands, covering the distance between shrubs on two legs without using their hands. This bipedal ability allowed them to stand upright and better observe their surroundings. It can be said that one of the most significant achievements of walking on two legs was the freeing of the hands. Hands that were previously used to bear the body's weight during movement now allowed Australopithecus to carry food, tools, and even their offspring while walking. Additionally, the liberation of the hands provided an opportunity for them to, later, around 3.3 million years ago, use their hands for making and utilizing tools. Australopithecus were small creatures roughly the size and weight of a modern 12 to 15-year-old human child. They were highly vulnerable to predators, which is why they lived in small social groups. Some researchers believe that early hominins lived in mixed-gender groups of varying sizes, likely separating for daily activities and reuniting at their shelters in the evening. Their brain volume ranged between 450 to 500 cubic centimeters, which compared to modern humans, Homo sapiens, who have a brain volume of around 1,400 to 1,500 cubic centimeters, is much smaller, approximately the same size as the brains of modern chimpanzees. Given their brain volume similar to that of chimpanzees, and assuming that the behaviors of our closest living relatives, chimpanzees, could have been exhibited by our last common ancestor and its descendants, it is conceivable that the cognitive and technological capacities of Australopithecus were comparable to those of modern chimpanzees. Hunting by Australopithecus is not out of the question, as male chimpanzees today sometimes hunt smaller mammals, though they rarely use tools such as sticks, bones, or stones in the process. Early hominins might have had slightly different behaviors. For example, Australopithecus may have been capable of group hunting or defending themselves by throwing stones at other animals or rival groups of hominins. However, it is important to note that these early human ancestors were likely not capable of pursuing and hunting large animals, and were probably more often preyed upon by predators rather than engaging in hunting themselves. It seems that Australopithecus might have scavenged for the protein they needed. For example, when carnivores such as lions, leopards, or hyenas hunted and consumed their prey, leaving behind the remains, Australopithecus waiting in the shadows would have come to scavenge and feed on the leftover carcasses. It is possible that Australopithecus could have used primitive stone tools to butcher parts of animal carcasses and transport them to safe places for consumption. To compete with other animals for protein resources, Australopithecus would have needed to create stone tools. If suitable raw materials, such as cobbles capable of flaking, were not readily available near their settlement, Australopithecus would have identified, moved, and transported appropriate cobbles to their work sites. This behavior, not yet observed in chimpanzees, indicates a more complex level of technological skill and planning in these early hominins. Evidence on the bones of animals contemporary with Australopithecus clearly indicates that they could remove remaining meat from the skin and bones using flake tools or using Oldowan cobbles, break long bones and skulls of dead animals to access marrow and brain. Female chimpanzees demonstrate greater skill and persistence in tool-related activities, suggesting that female Australopithecus might have played a significant role in the creation and use of tools as well. Additionally, given that chimpanzees, although to a limited extent, exhibit abilities related to learning, expressing emotions, and understanding the motivations of others, and have specific teaching behaviors that can be passed from generation to generation, it is possible that similar capabilities were present in Australopithecus. Australopithecus went extinct around 1 million years ago, but the creation of Oldowan toolkits continued almost unchanged by other hominin species throughout the lower Paleolithic period until about 500,000 years ago. In 2001, a fossil of an African antelope's hand bone, dating back 2 million years, was discovered in Tanzania. This fossil showed signs of carnivore tooth marks, as well as evidence of breakage by Oldowan stone tools. This discovery is one of the key pieces of evidence for scavenging among early hominins, and indicates that these creatures fed on the remains of prey left by other carnivores. In the Oldowan toolkit, there are no specific hunting tools like spear points. Instead, the tools primarily consist of flaked cobbles and sharp-edged flakes, which indicate a focus on scavenging rather than hunting among Australopithecus. The time period of Australopithecus reflects an era of extensive speciation, and ultimately the genus Homo evolved from one of these numerous branches. According to some scientists, the best candidate for this transition is the species Australopithecus Afarensis. The first discovered specimen of the Australopithecus family, which led to the naming of this genus, was a child skull fossil found by Raymond Dart in 1924 at the Taung mine in South Africa. This species was named Australopithecus africanus, and the fossil was given the nickname Taung Child. The Taung Child lived approximately between 2.3 million and 2.8 million years ago. In another discovery related to the Australopithecus family, a fossil was found in northern Kenya. Based on the characteristics of its femur and tibia, it was determined that this creature walked on 2 legs, and it was named Australopithecus Anamensis. Anam is the name of the region where the fossil was found. This species lived between approximately 4.2 million and 3.9 million years ago. In 1999, another Australopithecus fossil was discovered in Ethiopia, dating back 2.5 million years. The discoverers named it Australopithecus Garhi, with Garhi meaning surprise in the local language. Alongside this hominin fossil, remains of an animal were found showing cut marks made with stone tools. Until that discovery, archaeologists believed that the first tool makers and the earliest tool-making ancestors of modern humans were a species of hominin called Homo habilis. However, this finding shifted that recognition, showing that Australopithecus species were also toolmakers, using Oldowan tools at least for butchering dead animals, and possibly for crafting wooden and bone tools. In 1974, in the Afar region of Ethiopia, a relatively complete fossil, nearly 40% of the skeleton of a new Australopithecus species, was discovered. This remarkable find was made by the renowned American paleoanthropologist Donald Johanson and his team. The new species was named Australopithecus Afarensis, after the location of the discovery. The specimen belonged to a female approximately 12 to 18 years old who lived about 3.8 million years ago in East Africa. On the night of this significant discovery, Donald Johanson, inspired by a suggestion from a team member and the Beatles' song Lucy in the Sky with Diamonds, chose the name Lucy for the fossil.
Tangerine trees and marmalade skies. Somebody calls you, you answer quite slowly. A girl with kaleidoscope eyes. Cellophane flowers of yellow and green, towering over your head. Look for the girl with the sun in her eyes, and she's gone. Lucy in the sky with diamonds. Lucy in the sky with diamonds. Lucy in the sky with diamonds.
Based on the skeletal remains of Lucy, she was approximately 1 meter tall and likely weighed around 30 kilograms. The estimated height for males of this species is about 130 centimeters with an approximate weight of 45 kilograms. In addition to the discovery of Lucy, several other significant finds related to Australopithecus Afarensis have been made. One of these discoveries is a fossilized family of 13 individuals known as the first family, found in Ethiopia. This family lived around 3.4 million years ago and likely perished due to a natural disaster, such as a flood. In another significant discovery in Tanzania, fossilized footprints of hominins dating back 3.5 million years were found in volcanic ash. These footprints are likely attributed to Australopithecus Afarensis. Alongside the hominin footprints, prints of other animals were also discovered. Archaeologists believe that these hominins and animals were fleeing from a danger, such as a volcanic eruption. The footprints belong to 2 adults and 1 child, and it is clear that the owners of these footprints were walking on 2 legs. Perhaps the most important discovery regarding Australopithecus Afarensis occurred in 2010, which pushed back the timeline for the creation and use of stone tools by hominins by 1 million years. In 2010, an article published in the prestigious journal Nature revealed that Australopithecus Afarensis was the earliest hominin known to make and use stone tools. Clear evidence of cut marks made by stone tools was found on animal bones from 3.4 million years ago. The significance of this discovery was such that images of these cut marks under an electron microscope were featured on the cover of Nature. Five years after the groundbreaking discovery in 2010 and 2015, scientists were able to uncover not only cut marks, but also stone tools used by Australopithecus Afarensis, dating back 3.3 million years at the Lomekwi site in Kenya. These findings help to further clarify the history of stone tool use by Australopithecus Afarensis. As previously mentioned, various species of Australopithecus lived across different regions of Africa between about 4.5 million and 1 million years ago. One of the most recent discoveries related to Australopithecus was made in 2008 in South Africa by Matthew Berger, the 9-year-old son of the lead excavator, Lee Berger. This species, named Australopithecus Sediba, dates back approximately 2 million years. Similar to other members of the Australopithecus genus, it walked on 2 legs, had long arms, and had a brain size comparable to modern chimpanzees, around 450 to 500 cubic centimeters. As previously mentioned, scientists have categorized Australopithecus species into 2 groups, the more gracile forms and the robust forms. The robust forms, classified under the genus Paranthropus, include 3 species, Paranthropus Robustus, Paranthropus Aethiopicus, and Paranthropus Boisei. These species lived between approximately 2.7 million and 1 million years ago, coexisting with other Australopithecus species such as Australopithecus africanus and Australopithecus Sediba in East and South Africa. The main difference between Australopithecus and Paranthropus is the significantly larger size of the jaw and teeth in Paranthropus. This difference in size is attributed to natural selection pressures favoring individuals with larger teeth for chewing and processing tough, hard seeds. Paranthropus species required robust jaws and strong chewing muscles, which is why they had a prominent sagittal crest on their skulls to anchor these large muscles. The first example of Paranthropus was discovered in 1938 by Robert Broom in South Africa. Initially, this specimen was named Australopithecus Robustus, with robustus meaning thick or robust in Latin. Paranthropus robustus lived between approximately 1.8 million and 1.2 million years ago. The second example of Paranthropus was discovered in 1959 by the renowned anthropologist Mary Leakey in the Olduvai Gorge in Tanzania. Mary Leakey and her husband, Louis Leakey, named this new species Australopithecus Boisei in honor of Robert Boisei's financial support for their discoveries in East Africa. This species was later classified under the new genus and species name Paranthropus Boisei. It lived approximately between 2.3 million and 1.2 million years ago in East and South Africa. The third member of the Paranthropus family, known as Paranthropus Aethiopicus, dates back to around 2.7 million to 2.3 million years ago. It was first reported in 1986 from Ethiopia. This species is famously known for the black skull. The journey of reconstructing our human ancestral past is akin to piecing together a magnificent puzzle. With just a handful of fragments in hand, researchers boldly strive to form insightful scientific hypotheses about the larger picture, continuously refining their understanding with every new piece uncovered. Each discovery deepens our appreciation for how our ancestors lived, interacted with their environment, and cultivated the traits that shape who we are today. This remarkable endeavor demands precision, patience, and unwavering dedication as we unite to assemble a profound view of human evolutionary history. The vital mission of archaeologists in this thrilling process of exploration and discovery is to uncover and piece together this fascinating history.